A vertical asymptote is a vertical line in which a function approaches but never touches or crosses. We can identify vertical asymptotes by identifying values of x that make the denominator 0. In this example, let me factor the denominator into x plus 4 times x minus 1. If I want to calculate what values of x make the denominator 0, I could set the denominator equal to 0 and solve for each factor equal to 0. I have two vertical asymptotes, one at negative 4 and the other at positive 1. If I look at a graph of this function, you can possibly recognize or imagine a vertical line at negative 4 and a vertical line at positive 1, in which the curve is supposed to get closer to but never touch. The software and graphing calculators can sometimes be deceptive because of resolution. We can't show the curve getting closer, not touching. It eventually shows that it touches. But you can maybe imagine those vertical lines. Also, a topic that's directly related to this is the topic of domain. What values can we plug in for x and get y values? Well, if we look from left to right, we have values of x that are being graphed all the way until we get to negative 4, and then we cannot have negative 4 for x. So there's a restriction on what x cannot equal. That also happens again at positive 1. As we go from left to right, we can write the domain in interval notation like this. From negative infinity to negative 4, don't include negative 4. So that's this left part of the curve. In union with negative 4 until we get to 1, not including negative 4 or positive 1. That's the middle part of the curve. In union with 1 to infinity. And that would be the domain of the function. That says that all of these numbers, all real numbers, will work in the function except for negative 4 and positive 1. Let's look at a second example. G of x equals x plus 3 over x squared minus x minus 12. Again, I'll factor the denominator. And notice in this problem that the x plus 3's could cancel. Now, just like the last problem, I can identify the denominator, the values of x that make the denominator equal to 0. The denominator equal to 0 would be give us values of x that we cannot have. If I solve for each part of this, x equals 4 or x equals negative 3. Well, I canceled out the negative 3 or the x plus 3, and that's where this negative 3 came from. This is not going to be a vertical asymptote. This is actually going to create a hole in the function. X equals 4 is the vertical asymptote. Also, for this hole, we can identify the y value for that hole. If we take the final version of our function after we cancel the x plus 3's and plug negative 3 in for x, we get negative 1/7. So we'll have a hole on the function at negative 3, negative 1/7. So remember, a vertical asymptote at 4, and then a hole at negative 3, negative 1/7. Here's a graph of this function. We said we have a vertical asymptote at 4. You can maybe imagine a vertical line at 4 where the curve doesn't touch. We also said that we'd have a hole at negative 3, negative 1/7, which is here. I'll graph that with an open dot. We don't see that on most graphing calculators or graphing calculator software, but there really is a hole there. You can check the table of values and see that it's there. You'll see an error. You'll see an error at -3 and also at 4. Well, once again, if we look at the domain for this function, coming from the left, the curve goes all the way off to -infinity and comes up to -3, but does not include -3. And then the curve goes from -3, not including -3, up to +4. And then the curve goes from 4 to infinity. So here is a graph of the function. I could identify this point as -3, -1/7. I could identify my vertical asymptote as x equals 4. Let's look at another example. Actually, I'll give this one to you for practice. H of x is equal to x minus 4 over x squared plus 2x minus 24. Try to determine where there are vertical asymptotes and holes, and also determine the domain. Come back to the video whenever you're ready to check your answer. If I factor the denominator, I have x plus 6 times x minus 4. The x minus 4's cancel, which tells you that we'll have a hole in this function. If I set each part of the denominator equal to 0 and solve, I see that I have a hole at 4 and a vertical asymptote at x equals -6. For the hole, we can find the y value by plugging 4 back in 1 over x plus 6 in that version of the function.